Good morning. Today we will be looking at unit vectors as well as position vectors. Two very short exercises, so we've put these two things together. Now, first of all, a unit vector is a vector that has size magnitude 1. So the length of the vector being 1 is called a unit vector. For any vector, we can find a parallel vector of magnitude 1 and we would be calling this the unit vector. So here we have a question. Find the components of the unit vector u parallel to vector v. Now let's start with vector v and let's see what the size and magnitude of vector v is. That turns out to be 5 units. When we square the numbers, add them together and square root them, we have 5 units. So vector v is 5 units. So if we want to find a parallel vector u and comparing it to vector v, parallel to vector v, then we will have to divide vector v by 5, and that will give us vector u that will have magnitude 1 instead of 5. So we will divide vector v by 5. Now if the numbers don't work out nicely, you just leave your answer as fractions. So we have 1/5 of 3 and 1/5 of 4. And the vector u, that is parallel to vector v, is 3/5 and 4/5 for each of the components. Very simple to do that. Okay, so now we have exercise 13F. Now I want you to mainly focus on question 1. Question 2 will actually be a little bit easier once I have done the next lesson, so you can go back and do question 2 later on. But question 1 is in relation to the unit vector that we've just covered. Okay, now we'll look at position vectors. I'm going to explain this to you first of all, and then I'll show you how you very simply work out what position vectors are. So don't copy this first part just now. Okay, right. So here we have a vector OA. And that would be a position vector of a coordinate, a point A, relative to the origin O. And we would write that as vector A. Now what I mean by that is that it is a coordinate A that starts from the origin, and then we create a line going from O to A, the origin to coordinate A. And we can write that as vector A. I'll show you that in a diagram in a second. OB is called the position vector of point B. Now point B, remember, is the coordinate B. And remember, a coordinate is just a dot on a coordinate axis. Okay? But if we start the line going from origin to that coordinate B, we can call that line, that vector, B. And that's what that would look like in a diagram. So here we have the coordinate A, and if we draw a line going from the origin to the coordinate A, then we can call that the vector A. If we have the coordinate B, and we have a line going from the origin to that coordinate B, we can call that vector B. Okay, and it's the position vector because it's in relation to the origin. So it's where the coordinate is in relation to the origin, and it's a vector that is created from that. What we want to be able to work out though is how we can find what the vector from the coordinate A to the coordinate B is, and vectors like that. Now if we were to do the indirect journey from vector A to vector B, using the two vectors that we have here, we would go backwards through A and then forwards through B. So we would go from A to O and then from O to B. So minus A and then plus B. We can write that out as follows. That AB in an indirect journey would be A to O plus O to B. Okay, you can see that there. Now A to O is just simply minus O to A plus O to B. And minus O to A is minus A plus B. Or, as we like to have it, B minus A. Now to get the vector that starts at coordinate A and finishes at coordinate B, we will use the position vectors A and B, and we will do the second letter minus the first, B minus A. And that's the proof of it. Now doing it in a practical sense is actually very simple to do. So let's look at an example. So for the vector joining any 2 points, any 2 coordinates A and B, the vector that we would create from point A to point B would be called AB. It's simply worked out by looking at the position vectors B and A and doing B minus A. Okay, so let me show you how you would do that very simply. Now, if you have the coordinate A and B, first question, write the components of position vectors A and B. Now, the coordinate 2, 4, if that's to become the vector starting from the origin and going to 2, 4, you will also go along horizontally 2 and up 4. So the position vector of A will also be 2, 4, but written as a vector. The position vector of B will also be going horizontally along 2 and down horizontally along 10 and down 2. So the position vector B will be written as 10, negative 2, but as a vector. So that's us now given the vector for A and B, starting from the origin and ending at the coordinates A and B that have been given in the question. So it's the same numbers that you use, but you write them as vectors. So that's us got the position vectors A and B. So the components of A to B, looking at the position vectors that we've created, we're going to now do B minus A. Okay, so it's looking at the top 2 numbers, 10 minus 2 and minus 2 minus 4. So here we have the vector A to B, which is 8 and minus 6. Now, if we're looking at this, I want to show you another way of doing it as well, because you do have this method here to be able to do that. But if we start at A and we finish at B, let's look at the 2x numbers. What do we do with these 2x numbers to go from 2 to 10? We go up 8. And that's telling you that for the journey to go from A to B along the x-axis, you would go along 8. From 4 to negative 2, you would go back 6. So the journey to go from A to B, from 4 to negative 2, back 6, and that would be represented by a negative 6. So here we have a little calculation to do it, and that's a practical way, a common sense approach of being able to do that as well. Okay, now the last part of the question is not anything new, that's just a magnitude question. So calculate the magnitude of A to B. So you had to make sure you found what the vector AB was first of all. And then the magnitude of that is based on the vector AB. So you would just do your usual magnitude formula working. 8 squared plus negative 6 squared. And that gives you a size, a magnitude of 10 units. So finding the position vectors and the components of vectors from one coordinate to another is actually quite an easy process to do. So you'll get to practice that in exercise 13G. And you can work from questions 1 to 2. Now, as always, if you have any queries, anything at all, please don't hesitate to message your teachers who will get back to you with some advice, and send in your marked work so we can check your working. And good luck with everything.